Hi everybody, back to Cook YouTube again. What I'm going to do today is I'm going to analyze circuit, or let's say we are looking for the current flowing, at each across each resistors, and also voltage drop, across each resistors, and also find voltage at each, point. So what I'm going to do, I'm going to use piece by piece and also show you how to analyze the circuit or using the simple hand calculations, and in addition with solve problem by using a matrix. uh, for example, in the term here, I set up matrix and I have four unknowns. I have I1, I2, I3, I4, and I5. uh, I can write matrix in the form A multiplied by B equal to C, and then I simply looking for B by multiply A inverse to A. Here I got identity matrix, and that's where you can solve for B. So the problem is that how to find A inverse. So we go to our back to the basic for inverse matrix calculation. Actually, we are studied that since high school, but maybe many of you forget already. So we go to refresh, how to find inverse matrix, again. As for the, I also upload my note materials for this YouTube on this website. Okay, so you simply go to my website here, and you can see, or you can get uh, save or print out for future reference. Okay, so let's take a look at the simple circuit here. I have two source voltages, V1 and V2, and I have V2 become 7 volt DC, and then V1 is 3 volt DC, and then I have R1 4 ohms, R2 3 ohms, R3 with 2 ohms, and R4 6 ohms. And to just recall, sorry, to do to get parts or components, you need a ground, and this one is what, AG and D, right? Okay, if you recall that. And this one I just used Control G to draw to get parts, so I just simply put VDC. Okay, and if you want to rotate around, Control R as rotate, and then R you simply type R. Okay, now let's do analysis. After you save the file, you do simulation, and then you go to the main menu analysis, and you go to our submenu display schematic. You want to see the voltage, you hit voltage display, and you want to see the current, you hit the current display. So these are all the voltage and the current flowing at in each resistor. Now what I want to show to you is that what I have in my lecture here. Let's get okay, start from the page number 1. This is what I have on my lecture. As you can see that I draw the circuit, so it's the same thing as in the on the piece. What I have here is the, let me get a pen. Oops, right, sorry about it. So close right pen here. I don't want this guy show up. I don't know why it show up here. So let's go to markup. Oops, I don't know, it's always, oh, alright, okay, pin on. Let's see if we can do it. Nope. Okay, that's better. Um, well, just take a look at this quick. So I have I1 is coming flowing through our 4 ohms resistor, and then I define the direction of the current, as shown here. So I have I1, and then I2, I3, I4, I5. So in this case, don't worry about the direction of the current. If after you saw, for I1 to I5, and if you have the positive sign, that means you have the right direction of the current. But if you have the negative sign for that specific I, that means the current is flowing opposite direction as you define. Let's take a look at this one here. You go to PSpace. You take a look at 1.8 amp. So it's flowing, as the direction that I defined. For I2, okay, it's the same thing. So when you saw for I1, I2, it should come out to be the positive sign. Now for I3, you can see that is flowing in the opposite direction as you define. So I3, when you saw I3 has to be your negative number. Alright, so don't worry. When you have I3 to be a positive number, that means the direction is going to be opposite whatever that you are specifying, right? For I4, you click on a 466.67 milliamp, so you get the right direction, so you don't have to reverse the direction of your current. And also I5, the same thing. So only I3, when you solve, it's going to give you a negative number. And from the last one here, you can see I have I3 only to be negative sign, right? So agree with whatever you have on the PSpace. Okay, so the reason I mentioned earlier that why we have to do our PSpace first, because you don't want to waste your time when you set up equations, right? You have 5 unknowns, so you're looking for 5 equations to be able to solve, for these unknowns, right? If you set up the equation wrong, that means you're gonna waste your time, So in this case, I just show you step by step. You apply KCL. This means our incoming current is going to equal to the summation of outgoing current. Take a look at the node 1, here. This is node number 2. What we have is node 1. You have I1 incoming current equal to I2 plus I3. This is outgoing current, right? And node number 2, you have incoming current, which is I2. It's going to equal to the summation of outgoing current. Sorry, I don't know why it happened here. So that's why you have I2 equal to I4 plus I5. Now you apply KVL. Take a look, number 1. The voltage, summation of the voltage is going to be equal to 0, right? So you have a 7 volt equal to the voltage drop across 4 ohm resistor. So that's why you have a 4I1. You take a look at the clockwise, right? And I3 also are flowing in the clockwise direction. So you have 3I3. That's equation 3. Now take a loop number 2. You have the source voltage is 3 volt. And then you have the voltage drop across what 2 ohm resistor here, and I5 is the direction of clockwise, so you have 2I5 just right here. And then also I3 have the counterclockwise, so you have to put the, what did I do wrong here? Oh, okay, sorry about that. 3I3, so that you put a negative sign here. This give you equation number 4. And for loop 3, you have clockwise current, so you have 6I4, and equal to, or you can put negative sign here, because I5 is the counterclockwise current, so you have 2I5. Okay, clear. So as I mentioned earlier, to be able to make sure that you set up the right equations, because you don't want to waste your time, so I check all of this from the circuit. I have only I3 become negative 66.67. I got it from PSpice. I1, I2, I3, I4, I5. So you check all equations that you have. Equation number 1, you have I1 what equal to I2 plus I3. So I have I1 equal to I2 plus I3. I3 is negative, so I have 1.8 equal to 1.8. Equation number 2, you look in here, I2 equal to I4 plus I5. So I have I2 here 1.867 equal to I4. My I4 is 466 milliamp, and then my I5 is what, 1.4 amp. And also equation number 3, sorry, 7 volt equal to 4 I1. My I1 is 1.8 amp. It's positive number, right? Plus 3 I3. My I3 is negative number, so I'll multiply 3 with negative 66.67, or 10 to negative third. So I have on the left equal to the right, so that's why I put the right sign over there. And number 5, 6I4 equal to 2I5, so I make it equal here. Right, so the next step is that how to solve for I1 to I5. And in this case, just to refresh you about matrix basic, let's go through equation here. I rearrange your equation, move everything, I1 to I5 to the left, and leave just only number on the right. So from equation number 1, what I have I1 equal to I2 plus I3, right? So I move I2 to the left, move I3 to the left. So I have I1 minus I2 minus I3 equal to 0. Same thing as the equation number 2. Okay, so that's all I have. Now the next step, how to do the matrix setup. Let me work on this guy here. I pick up pen width. Sorry, it's too big. Okay, now to set our matrix, the first thing you need to do, so you don't get confused, you set up I1 to I2, I3, I4, I5, right? Metric dimension of 5 by 1. And then on the right, you have also the matrix dimension is also 5 by 1, because you have pick up 0, 0, 7, 3, and 0 here. And now you need to set up matrix A, which is actually become a coefficient of each I You need to set up, matrix so or it's end up, to be your 5 equations, just where you have right here. Okay. So for equation number 1, you pick up 0 here, and to multiply, um, I1, I2, I3, I4, I5, and you can see your you need to multiply this coefficient. Okay. Let's go through this one first. To be able to multiply matrix, if you notice, the dimension of matrix A, I mean the number of columns have to be equal to number of rows of matrix B. So this is why you have 5 columns, and for matrix B you have 5 rows, so they have to be equal, right? And you end up with the matrix C with the dimension 5 by 1. Actually, come from 1. It's from the number of columns of matrix B, right? And 5 is from where? From the number of rows of matrix A. So just keep that in mind. Okay. So that's why I have 5 have to be equal to number of columns matrix A. 5 is the number of rows of matrix B, and then 5 is number of rows is going to become number of rows of matrix C, and then the number of column of matrix B is going to be your number of column of matrix C. So they mix, this come from A and this come from B, right? But you pick up a number of column, and this one you pick up a number of rows, right, of matrix A, right? Just remind you about our matrix. Now to do what? To set up equation, you need to multiply, let's say 1 here. Let's take a look at the, I put C1, 1, right? Because it's row number 1 and column number 1. For this guy, you have like C, row 2 and column 1. So you pick up you need to multiply, columns, row 1 of A multiplied by column of B, right? So that's how you define, right? Not to get confused. So the way you multiply this guy here, and this one here, and this one right here, and this one right here, and this one right here. So that's why I have 1 here, because the coefficient of I1 is 1, right? And coefficient of I2 is what? -1. That's why I put -1 here. The coefficient of I3 is -1, so that's why I put -1 here. And you don't have I4 and I5, I put 0 and 0 here. Okay? So let's do it again. Now what about equation number, let's say number 3. So this is element what? Matrix C, row 3, column 1, right? And that's why you need to go to matrix A, pick up row 3, sorry, and then you multiply with the column 1 of matrix B. So that's why I have this is equation number 3, right? You have 4I1. I put 4 here because you have to multiply, 4 to I1. You don't have I2, right? Next step, you need to multiply this one to I2. So that's why I have 0 here. Now for I3, I have what? 3. Next step, you need to multiply, 3 by I3. That's why I have 3 here. And you don't have I4 and you don't have I5, so I have 0 and 0 here. Okay? Alright, next step is that to solve the problem using a matrix, what you need to do is you take a look at this. It's in the form of A multiplied by B equal to C, and you want to find only B. What we do is we multiply A inverse, to both sides of equations. So you have A inverse, and this one you have A inverse multiplied by C. And you know that this is identity matrix, right? A inverse multiplied by A, you get I. When identity matrix multiplied by anything, it's going to give you the same, right? To be B. That's what we call identity. And now to find A inverse, that's going to be your somebody already forgot. We call pain in the neck. Simply, A inverse equal to 1 over determinant of A multiplied by A adjoint, or equal to 1 over determinant multiplied by A cofactor transpose. Okay, just to give you the general idea how to find A cofactor, let's say A inverse, I make it matrix simple. So I do a 3 by 3 matrix instead of do 5 by 5. It's going to take too long. Okay, the first step you need to do, step 1, you need to find determinant, right? So the way I do is just do the basic one. There are many alternate ways, to find cofactor and determinant, but I'm going to use the basic one so you can recognize that in the future. But if you want to shorter or faster, you need to go through some specific way to find A inverse. Okay, what I have here, I want to find determinant. So I set up 1, -2, -3. It's difficult to see here. So let's blow this up a little bit so you can see better here. Alright, so that would work. Now to find determinant, I put multiply, here, and then I have to do, 3 of them. So that's why I have I put 1, -2, -1, -2, and 2. I add another column. So that's why I put 1, -2, and 1 put in here, and also the next column, -1, 4, -3. I also add more columns. So I have 5 more. I have a total of 5 columns to be easy to find determinant. So I have number 1 here, number 2 here, number 3 here. So I have number 1. I have 1 multiplied by 4 multiplied by 1, right? 1, 4, 1. So I give 4. And number 2, I have -1 multiplied by 0 and multiplied by 2. So I got 0 because I have 0 here. And number 3, I have 0. Okay. So I have 0 multiplied by -2 and -3. So it gives you a 0. And also you have number 4, number 5, number 6 here. I have 0, so it ends up 0. For number 5, I have a 0, so I end up at 0 here. And for number 6, I have -1, -2, and 1. 1, -2, -1. That's give you 2. So what you need to do, and you know that you have to add 1 to 2 and to 3, and then subtract or -4, -5, -6, right? And I end up with determinant to be 2. This part is missing. It's my mistake from the scanner. Now that's why I put step 1 to find determinant. Keep in mind what we are doing here. We are looking for a inverse. Now the next step, you need to find cofactors. Okay. To find a cofactor, actually this is you can do a adjoint. That's why I have the element of matrix a adjoint 1 1 1 2 1 3, okay, etc. Now actually I did this wrong, totally wrong. I should put cofactor, not adjoint. Okay, sorry for my mistake. So this has become a cofactor, not adjoint. Okay. To do that, you simply what you find determinant. Okay. For example, you want to find a cofactor, 1 1. So you go through row number 1, right? And then this is row number 1 and column number 1. So you just pick up only whatever left over and you find determinant. And don't forget about to do the -1 to the power of number of row and number of column. Add them together, because you're going to have a positive and negative sign. So this one I have a determinant to be a 4 minus 0, right? I have 4. And this one is -1 to the power of second, right? So it becomes positive. I have 4 here. Now you do the next move. A12. This means you are pick up row number 1, column number 2. So you have left over this guy and this guy. So that's why I have a -2 and 0, 2, and then 1. And don't forget -1 to the power of a number of row plus number of columns. So this is to the power odd number, right? -1 to the power odd number. You end up with negative sign here. And you have a -2. You have 0 here. You have 2 here. You have 1 here. So this means you get a -2 and this way, and this is 0. So negative and negative just give you a positive number. Oops, I don't know what happened here. Sorry about that. So by doing all of this, I can I get my a cofactor as shown here. So it become a 2, a 4, 2 make -2, 1, 1, 1, 0, 0, and 2, as you can check by yourself. The next step is you need to find a cofactor. Okay, this is still wrong, so it's not adjoint. Transposed. What does it mean, transposed? Transposed just mean you simply when you have you want to find a cofactor transposed. I show you just right here. For the element here, you are, let's say element a cofactor transposed. You want to find element 1 1. That's mean row number 1 and column number 1, which is here. You simply have to take a cofactor and then switch this around. That's mean if I have a cofactor here 1 1, you want to do the transpose. to be a cofactor transpose, you simply switch, this one around. That's mean row is going to be column and column going to be row. So for this diagonal here, it's never changed, right? Because this is A11, this is A22, this is A33. But for let's take a look at this one here. This won't take long for you to understand. For this is a cofactor of row number 1, right? And column number 2. When you want to do the transpose here, you simply switch around to be A to 1. So that means A12 here is going to show up at the A cofactor transpose at to 1. So that means row number 2 and column number 1. So that's why you have 2 here. This is the row number 2 and column number 1, right? Or some people just simply, like do a switch around like this. You draw a diagonal line and then you just switch this guy around. This is just like a center line. So 1 is going to switch to be here. So 0 is going to move up there. So that's why I have the same thing here. You compare 0 going to be over there, right? And 1 going to be here. Okay, so that's how you do a transpose. Now step number 4, you want to find a inverse, right? You simply do a inverse. Go back to a inverse equal to 1 over determinant of a cofactor transpose. So don't forget to divide, this one by determinant, which is 2, from a matrix A. Okay, hope you understand about that. And now for the problem, okay, this is the problem that we are start analyze the circuit. I have my matrix A with the size of 5 by 5, so it's a bit, take time. So that's why I cheating a little bit. I go to internet and do a inverse matrix calculator online. So I end up with this is my A, and I end up with my A inverse here. And then I'm looking for B, which is I1 to I5, and my C, is 0, 0, 7, 3, 0. It's the dimension 5 by 1, right? And I multiply this together, I give my solution, just like you have on p-space. Alright, let's check this out. This is my p-space, right? So oops, sorry. Alright, so this is my I1, 1.8, right? Where's my I2? I2 is 1.867, and my I3 is become negative, right? Because we define the current flowing, on the opposite direction. So this is 66.67 milliamp. And then I4, this is 466.67 milliamps. Exactly what you have by doing a matrix for the calculation. Okay, so that's all about how to use matrix to analyze circuits. And then you can check, by yourself, do hand calculation, work out by yourself again. Now you take a look at the circuit. PSpice give you this is a very potential, program that's give you many things that you can analyze, in parallel with your hand calculation. Well, you notice this is your the source voltage, right? So your the voltage compared to the ground here is definitely become 7 volt, and also have the current flowing through, the loop here, 1.8 amps, and your current here, um, it flowing as defined, as this direction, and this guy, flowing this way, and this guy also here. You take a look at their KCL, you can see that the incoming current is going to be equal to outgoing current. This is incoming current. This is incoming current. You add up them up, you're gonna have a 1.867, right? And for the node here, incoming current is what, 1.867 amp, and outgoing is what, 1.4 plus 466.67 milliamps. So that's give you exactly equal to incoming current. And you also be able to find, the voltage drop across each resistor. Just remind you, simply you multiply 6 by 466.67 milliamps. The same thing as you multiply by 2 with by 1.4. So let's give you a 2.8 volt. And this one, the voltage here, actually is define the voltage at this point. You would be surprised, actually not a big surprise, become negative because you have current flowing, to this direction. The current flowing from the higher voltage, right, to the lower one. So that's why this one have lower become negative, because the voltage at this point is 0 volt, right? So this is just something that I want to point out, for you. Okay, I'll see you in the next YouTube. Thanks for watching.